The overall goal of this procedure is to fabricate 3D carbon structures using conventional and non-conventional carbon microelectromechanical system processes with carbon sources of SU8 polymer and human hair, respectively.
20 years ago, we actually started a complete new process where we are replacing silicon as the major material for making MEMS devices, microelectromechanical systems. Our idea is that carbon is a better material than silicon for making these three-dimensional shapes. Specifically, we take a polymer precursor, pattern it, and then convert it to carbon at high temperature, around 900,000 degrees C, in an inert atmosphere. What happens in that process is the shape is preserved, but it shrinks. In other words, you have isometric shrinkage, and you end up with any 3D carbon shape you might imagine. That is called carbon MEMS. It is much less expensive because all I do is take a carbon precursor, a polymer, and pattern it in 3 dimensions and then convert it to carbon. Carbon comes in many allotropes, from diamond to graphite to glassy carbon. Depending on how I pre-treat the polymer chains, I can actually end up with a 3D carbon structure that's more graphitic or more diamond-like or glassy carbon-like. Today, the process of carbon MEMS will be demonstrated for you by my graduate student, Ehsan Shamlou.
To begin the polymer structure fabrication procedure, first set a hot plate to 95 degrees Celsius. Turn on a spin coater